Welcome to this custom deep dive. We're looking at a tech spec sheet today, specifically the Bolin Technology EX1030NXW Outdoor PTZ Camera. And my first thought when you sent this over was, well, why are you looking at a single camera that costs $8,000?
Yeah, right around $7,995 to be exact, which is a lot.
Right, it's a huge price tag. Like normally a camera at that price point, you'd expect someone wearing white gloves, delicately carrying it around a Hollywood soundstage.
Oh, absolutely. You just naturally assume it's fragile, like it needs a perfectly controlled climate. But then you actually read the specs we shared with you.
Yeah, this thing is definitely not built for a quiet studio. It is meant to be bolted to the top of stadiums or theme parks, even industrial sites. Okay, let's unpack this. Our mission today is to figure out why broadcast professionals actually require this extreme level of technology.
And what makes one single camera worth almost $8,000? To really justify that price point, we have to first examine the physical extremes this device is engineered to survive.
Right, because the spec sheet mentions it has a corrosion-resistant IP67 certified housing.
Exactly. So in practical terms, that means it is totally sealed against dust and it can literally withstand being blasted by water.
Oh, wow.
Yeah, and it's rated to operate continuously from, get this, negative 40 degrees Celsius all the way up to a blistering 60 degrees.
Wait, that is absurd. So it can just sit in a freezing blizzard or a baking desert, but it's a PTZ camera, right? Pan, tilt, zoom.
Right, it has to physically move to track the action.
Which makes it feel like they tried to mount a super delicate precision Swiss watch inside a heavy-duty snowplow. How does a camera actually keep a steady shot when gale force winds are battering the outside of it?
Well, what's fascinating here is exactly how it manages that synergy. It uses something called ZDP, which stands for Zero Deviation Positioning.
Zero deviation positioning, got it. So what does that actually mean?
So instead of your standard belts and gears that, can slip or vibrate, it uses these highly precise step motors and internal gyroscopes for its pan, tilt, and its 15-degree roll axis.
Okay, so it's actively sensing all the chaotic movement outside and then correcting for it in real time.
You hit the nail on the head. When the wind hits that snowplow exterior, the ZDP sensors instantly calculate the vibration. Then they adjust the Swiss watch interior in the exact opposite direction.
So the movements stay perfectly smooth.
Smooth, silent, and flawlessly targeted. The rough weather outside literally doesn't even register on the video feed.
That is wild. But, surviving a storm is really only half the battle. To be worth the money, it actually has to deliver an incredible image through all that chaos.
Oh, for sure. And you pointed out earlier that it uses a Sony Starvis 2 sensor with a 30x optical zoom. Plus, it has a synchronized long-range laser that projects uniform illumination up to 500 meters.
Okay, wait, hold on. I have to push back here. A 500-meter laser. That sounds like a massive safety hazard. Like, is it shooting an action movie laser beam?
I know. It sounds terrifying.
Yeah, how does this not permanently blind the athletes on the field or, the fans in the crowd?
It's not a sci-fi laser weapon, I promise. It is essentially an incredibly advanced, totally invisible infrared flashlight.
Oh, okay. Invisible. That makes way more sense.
Right, and the beam actually physically syncs with the 30x optical zoom lens. So as the camera zooms in, the laser narrows to match the exact field of view.
So it uniformly lights up that specific distance seen in pitch black.
Exactly, without overexposing the overall image or creating any weird dark spots.
That is brilliant, scaling the light to match the zoom level dynamically. But getting that high-quality, perfectly lit footage out of the camera is a whole other challenge. The documents list dual 3G SDI and NDI HX3 outputs.
Right, let's translate that a bit. So instead of running thick, proprietary broadcast cables all over a massive stadium, NDI HX3 lets this camera send massive broadcast quality video over a standard internet network cable.
Which means essentially zero lag.
Precisely. But if we connect this to the bigger picture, the real magic here is the Freed compatibility.
Freed. I saw that in the specs.
Yeah.
What does that protocol actually do for the end user?
So, Freed is completely revolutionary for live broadcasting. It allows the camera to continuously output its exact positional data. That means it's pan, tilt, zoom, and focus.
Directly to the broadcast truck in real time.
Yes, exactly. It tells the truck exactly where the camera is in 3D space.
Why is that so important? The truck already has the video feed, right?
Because that spatial data enables augmented and virtual reality productions. Say you want to project a giant 3D graphic seamlessly onto the field during a live game.
Right, like a glowing first down line or a massive team logo.
Exactly. The broadcast system needs to know exactly how the camera is moving so the graphic moves perfectly with it. Normally, you'd have to bolt all these clunky, expensive tracking sensors onto the camera to do that.
But with this Bolin camera, it's just baked right into the unit from the factory.
You got it. It handles everything internally.
So we really aren't just looking at a standard security camera. We're looking at a super rugged, AR-ready, laser-equipped broadcast powerhouse built to survive the harshest environments on Earth. So what does this all mean?
Basically, it means the standard for live event broadcasting has completely shifted. We are achieving studio-grade visual and data precision in environments where human operators would struggle to even stand upright.
Let alone hold a camera steady in those winds. It really makes you wonder, if a single standalone camera can illuminate a subject half a kilometer away in pitch black and automatically stabilize itself and feed precise 3D tracking data directly into a VR broadcast feed.
Yeah, it does raise a big question.
Exactly. How soon will human camera operators be entirely phased out of live outdoor sports and concerts? Maybe the future broadcasting doesn't wear white gloves at all. Maybe it just looks like a snowplow with an invisible laser attached.